Okay, welcome everyone. We will just give it maybe two to 5 minutes and just wait for other people to log in, and then we will start with our training for today. So welcome everyone. Thank you for joining us today. Our training today will be focusing on LONGi. So we're just going to give you a couple of minutes and then we can start with our training. Okay, I see people coming in, which is good. Can everybody see my screen?
Yes.
Perfect, perfect.
Alton, you can get started.
Okay, I think we can start with enough people. So anyway, how we're going to start today is I'll first do a small introduction of IBC, and then I'll give the training to LONGi and they will start with the training. So if you do have any questions, please drop your questions on the meeting chat. And then we'll be able to assist you with all the questions or answer to all your questions today. So as I mentioned, today our training is LONGi. So we will be focusing on LONGi, and I'm looking forward to this training as well. So now, as IBC, we offer, okay, so apologies. So as IBC, we offer modules, mounting, inverters, and storage systems. So on a module side and mounting, we do have our own in-house IBC modules, which we supply. And we also do have LONGi, Jollywood, and Canadian Solar. So our focus today will be the one and only LONGi modules. And yeah, hopefully all of you are ready for that one. On the inverter side, we do have SMA, Fronius, Victron, GoodWe, Attest, and SunGrow. So all these inverters are compatible for and also suitable for residential and also commercial, where we'll be looking for on the commercial side, we'll be looking at SunGrow and Attest, and then on the residential, we would probably be looking at Fronius, SMA, and Victron. On the storage systems, we do have SolMD, a local manufacturing company with their head office in Cape Town. And we do also have BYD. So all these batteries do offer commercial and residential solutions. Now, on our team, we do have Daniel and Helga. Daniel is the managing director, and Helga is the head of finance and operations. On the marketing side, we do have Zane and Carmen, who are responsible for the trainings and also the advertisements and marketing that you see on our on our social media. On the supply chain and sales administration, we do have Charmaine, Kim, um, Michaela, and Tanya, who are responsible for the administration of IBC. So in terms of getting stock out, getting stock in, these are the people who are responsible for that. And then on the accounting side, we do have Amo, who is responsible for the accounting of the company and the client. So on the sales side, we have our sales managers, two of our sales managers based in Cape Town. Based in Joburg. So we have Leo and Jason. So if you do have any inquiries in terms of a solution, let's say for instance a containerized solution, Leo and Jason will be your point of contact in the inland area. And on the coastal regions, that would be David, Ridar, and Carl, who are based in Cape Town. So it's very important that you know your sales manager. So if you don't know who your sales manager is, please feel free to drop in your email, and then we'll make sure that your sales manager gets in contact with you. On the technical side, in Joburg, we do have vessels. So if you do have any technical inquiries on the Joburg region, or let's say in Mpumalanga, Limpopo area, vessel will be your go-to guide. And then in Cape Town and the coastal area, that will be myself, Honte, and Jama, who are responsible for the coastal area. So if you do have any technical inquiries, if you need support, on-site support or remote support, you can then contact us. So every second week of the month, our sales managers do offer training, online portal training, just to help you understand how our portal is, how to maneuver around our portal. I mean, our online portal is actually very user friendly. However, if you do need assistance, your sales manager will then sign you up for our weekly or every second week training. So yeah. And then something that we recently brought up is now all our webinar recordings are now, you can now find them online. So if you do miss a training or want to revert back to a training because you want to understand a particular product or want to work on a design, you can go back to our webinar recordings and actually watch them again. So the recordings and all the slides will be available on our online shop. And then our sales deal of the month is we do offer free delivery for anything exceeding 500,000 Rand excluding VAT throughout the month of May. So if you do have an order or you can make use of this by making sure that this exceeds 500,000 Rand and we'll just throw in a free delivery for you. So if you want to know more about this, please contact your sales manager and then they will then they can then offer you the support or let you know the terms and conditions on that. We also do have another sales deal. So if you purchase IBC's mounting system for corrugated roofs, you will get up to 100 free corrugated metal sheet adapters. So this is perfect for solar installations, and our adapters are German certified. So please make use of this, and we will then throw in 100 free corrugated metal sheet adapters for you. So if you want to know more about this, your sales manager will be your direct contact. And then from myself, that is it. And I'd like to then give this opportunity to LONGi. So they will then start with the training for today. So Shorai, welcome, and looking forward to the training today.
Thank you very much. I'll take it from here. Good morning, everybody.
Good morning.
Right. Okay, let me share my screen. Good morning, everybody. Can you see my screen?
Oh, nothing at the moment. It's all dark. I think maybe it
All right.
might be from,
Okay.
yeah.
Okay. Let me try again. And now?
There we go. Perfect.
Okay. Thank you. All right. Okay. My name is Shorai. I'm the product manager for the Middle East and Africa for LONGi. And today I'm just going to go through some products and interesting products we have online, and also the products also we have also on the portal at the moment in South Africa. And my concentration is going to be more on the new technology as well. So basically, LONGi started in 2000. That's when it was founded. And going back, going forward to 2023, uh, LONGi had an operating income of 8.9 billion. Then also a net profit, which was attributed to the shareholders, 1.23 billion. Then also we had an R&D investment of 473 million. As you can see, we are more uh, uh, put more investment and put more on the innovation and development of new products to solve issues on the PV market. Okay, and also I just want to mention that LONGi also does not only concentrate on the module manufacturing, we also have monocrystalline silicon wafer business. We do monocrystalline manufacturing, with the silicon rod and also monocrystalline wafers. Then also we have what you call the monocrystalline silicon cell. Uh, That is your cell and also includes also the module after it's assembled. Then also we have what you call distributed photo voltaic solutions, which I'm going to discuss more in my next slides. That is the distributed for PV and also for CNI projects. And also it includes also solutions, that is your P cells and also after cells. We have also the utility plant system solutions, which includes also the ground mounted photo plants and photovoltaic plants and also grid uh, for utility as well. Then the last one, the fifth one, is hydrogen equipment solutions. So we also do manufacture of water electrolysis, hydrogen production equipment as well. With regards to the health finances, we are tier one, and also we are triple A in terms of bankability, with regards to manufacturing, finances, and also shipments, capacity, and also technology. And also uh, our three pillars include mostly the technology and innovation, which I'm going to discuss. Um, as you can see on the screen, this is the records from 2019 in terms of cell innovation. So we started in 2019, that is with a PERC, that is the solar cell with efficiency of 24. And also in 2021, we optimized and also we're the first one to introduce the TopCon solar cell with an efficiency of 25.2. In the same year, we also optimized the P-type cell of Top Gun to 25.19. Uh, Moving forward to 2023, on top, we actually did a cell, a tandem solar cell, with an efficiency of 33.9%, which is the highest in the industry. And also, we included now the heterojunction in the same year, that was in December last year, uh, together with the BC platform. Okay, sorry. Sorry, can you see the next screen? I think I've got a technical issue here. Okay, with LONGi product family, is it what you can see, guys? Can somebody just raise your hand if we see the next slide? I think I've got a technical issue.
Still shows records for the highest efficiency, sure, right?
All right. Okay. Thank you very much. Okay, let me try to sorry about that. Let me try to reshare again. Can you now see my screen?
Yes. If you can maybe try to move it and then we see if it works now.
Okay.
Yeah.
It's blocking me. I don't know what happened. It's not going through. It's not moving.
Hmm.
Okay. Let me try something. I'm sorry about that. I'm not in the office. I've got a shared office. I think it's the network which gives me a problem. I'm not sure.
Okay, we'll just give it a few minutes. But just for everyone to note, if you do have any questions, please feel free to drop it on the meeting chat, and we will then try to answer as much as possible. Yeah.
Can you see my screen?
Yes, it's still on that continuous innovation, achieving breakthrough. So maybe,
Okay.
yeah.
Yeah, maybe something went wrong. Yeah. So let me come out, then I'll come in again. I'll rejoin.
Okay, not a problem.
All right. Okay. Thank you.
Apologies for that, everyone. We'll just give it a short period of time, and yeah, maybe you can make yourself coffee while we try to resolve our technical issues. However, if you do have any questions, please feel free to drop them in the meeting chat. And just another thing, if you do need pricing or you need modules on LONGi, we do have available, so you can go onto on our online shop and you can be able to make a purchase there. However, if you do not have any login details, please feel free to drop your email and Zane will then send you a checklist to then fill in your company details, and then you'll be able to then have access to our online shop. Okay, we seem to be getting back online. Everything looks good. Okay, perfect. Okay, you are still muted. Once again, apologies everyone. I think we should have, this should be resolved by now, and then we will then proceed with our training. Everything looks fine on our side.
All right. Okay. Thank you very much for your patience. Let me just continue. Sorry for the delay. Um, in terms of innovation is in our DNA. So we started with HIMO 1, that is your PEC, that is your single cell. If you, with a it was not half cut, it's a full cell. Then we have also HIMO 2, then we had HIMO 3, then HIMO 4, and now we have HIMO 5. And also we have, I just want to mention also HIMO 5, we've got it in stock. We have the 570s and also 580s in stock. But all, and also we have the HPBC technology, which I'm going to also mention. We have also the 570s and also 580s also in stock at present in South Africa. So in terms of HIMO 6, we've got three series. We've got the first series on the HIMO 6 is the Explorer. Then we have the Scientist. Then we've got the Guardian and the Artist. And also all these modules, they adopt the M10 size. The M10 size is 182 by 182. That is a square cell. And you find it in 72 cell, 66 cell, and also 54 cell. So basically, on your BC technology, we don't have bus bar in front, so your cell does have a maximum absorption of light. So all the bus bar, they are connected at the back. As you can see on my screen, on my right hand, you can see that the cross-sectional area for the cell, it's actually uh, no bus bar in front. There's higher absorption of light. Then also it adopts the back contact. That's where the name came from. So what we have the Explorer right at the moment in stock. Uh, So it comes in 570s and also 580s. And this is for the distributed generation. And in terms of the appearance is good. The module is stable and high efficiency with regards to the power generation, then also safe and reliable. So focusing on the distributed scenarios, um, it can be also be applicable to logistics, traffic, transport, and carport, retail, and also education and manufacturing facilities, as well as household. So I'm going to also introduce you to what we call the HIMO X6 Max, that is the Explorer. This is more optimized with the high efficient cell. This cell is different from the one I just mentioned. The one I mentioned is 182 by 182. It's a square cell. But these cells, which I'm going to talk about, it's a rectangular cell technology, which is 182 uh, by 191. So this technology comes in different sizes with regards to the module. So we have a 2.382 by 1134 by 30 millimeter frame. So if we compare our previous modules and this module, uh, difference is only on the length side. The width side is all the same. Then with regards to the weight, the weight is just increased by at least one kilo. So let's talk about the HPBC. What does the HPBC stands for? The HPBC stands for Hybrid Passivation Back Contact, and this technology is only found from LONGi. So how did we come up with this technology? So we looked at the industry and also the technological route of all the cells on the market. And we find out that the BC technology is one of the technology which is going to integrate all the technologies. For example, the TopCon, the PERC, the heterojunction can be integrated into BC. So we looked at two aspects. That is your enhancement light absorption. So when we looked at this factor, we find out on the BC there's obstructed absorption of light. And you could, after comparing it to the TopCon, you could see that uh, you get an advantage in terms of light loss. Then the second one is the reduced composite loss. So what we did on this cell, we integrated what we call the passivation layer. As you know, the TopCon is what it means is 10 tunnel oxide passivation contact. And as what we did now, we introduced what we call the hydrogen passivation in the cell. So what it does, it actually uh, increase the absorption of uh, of of light into the cell and protect the cell from losing light. In a nutshell. So after doing all this, we actually removed all the bus bar. Then we put them at the back. As you can see on my right side, we've got an exploded view for the cell itself. So in front, there's no bus bar, which is high absorption. Then also we've got photoelectric conversion, which is actually caused by the passivation layer, which is the hydrogen passivation layer, which we use in our cell. Then the bottom line is the electric transmission. The electric transmission, it was enhanced due to a single line connection at the back of the cell. So this is just an exploded view. As I just mentioned, the top part of the cell is your no busbar, which means high light absorption. Then also we have the second layer, which is the passivation layer, which is hydrogen passivation layer, which actually increase the photoelectric conversion of the cell. Then we have the bottom layer, which connects the cell using one single line electrode uh, and increase the electric transmission. So these are the three pillars in terms of the innovation which we have done on the cell itself. Then let's go and just look at the difference between the HIMO X6 and also the non-BC with regards to light absorption. I've just mentioned it, but if you look, there's two different pictures. The other one have got a shadow due to the ribbon attached to it in front. Uh, the HAMO X6 is actually plain and it can actually absorb light. So we have seen that we have an improvement absorption by about 2.27% after we have done this enhancement of the cell. So this is just to recap what I've just mentioned. On your left is your previous technology, which was zigzag, and you can find that there's a lot of a Z shape, and there's a lot of resistance on the cell due to the soldering of these cells together in series. Then on your right, that is your BC technology with a single line connection on the back of the cell. So what we have done also, we have done an experiment to check the more advantages of the BC technology. So we looked at better performance at high temperature. So what we found out that these modules, they've got a beta coefficient, which is approximately minus 0.28%. per degree Celsius. So after comparing it to the TopCon and the PEC in this region, which is Shanghai, Sydney, and Dubai, we have found out that we had an improvement of 0.05% per degree Celsius compared to the PEC. Then an improved 0.01% per degree Celsius compared to the TopCon. So you can actually see that there's a significant change in terms of your temperature coefficient. So the modules can actually work optimal under high temperatures. Then the second one, it's better performance at low irradiation conditions. So what it means, the module can perform much better during cloudy days in cloud environment, also early morning, and also just uh, uh, for sunset, you can still generate energy from the modules. So if, in this diagram, you can actually see that after we did the comparison as well, we have an improvement of 2% compared to the PEC and improvement of 1.54% compared to the TopCon. So the modules, BC technology can perform better at low radiation conditions. That is also the second advantage. Then with regards to the low degradation, which actually gives you an extra long warranty, we have first year, it's 1% degradation on the module. Then from the second year going to the 30th year, you have a 0.4% degradation. And we give a warranty of 15 years, material warranty, and 30 years power guarantee. So at the end of the 30th year, you should be getting at least approximately 87.4% output warranty. Then the second also the last I want to talk about in terms of testing for us to be able to give such warranty. So we did what you call rigorous test on our modules. We do accelerated testing of aging the module. So what we do, we perform tests, for example, the DH1000, PID 192, and also we've got mechanical load, also dynamic mechanical load. Then we've got also LID, that is light-induced degradation. And the threshold, according to the IEC, requires less than 5% degradation. But if you look at the diagram, you can actually see after all these tests, LONGi is measured at 2% and less. That is your average degradation, which makes it a more reliable module under these conditions. So what we did also, we did just a comparison with the TopCon, the one you find on the market. You can see that there's the difference in terms of warranty of the product. Ours is 15 years compared to other suppliers on the market, which is 12-year product warranty. And all this data is coming from third parties, for example, TUV, which does, and also other centers like Renewable Energy Testing Center. So this is just what we do in terms of reliability testing of our modules, and we use advanced technology with regards to our climatic chambers and also advanced methods of testing our modules. So we do TC testing and So that was our laboratories where we do the testing, and all the tests are done according to the IEC standard. Then in terms of process system reliability assurance, we've got what you call during manufacturing incoming material control. Actually, we use also the same standards, and we have manufacturing quality control. So on the manufacturing quality control, we have automated our lines, and we've got 22 level manufacturing processes, 338 process controls, and 153 quality inspections. Then for the final product, that is your finished goods, reliability control, we've got what we call monthly, quarterly, and annually reliability performance test, which we do on the raw material and also on the final product as well. Uh, we have a comprehensive standard quality control system, that is your ISO 9001, then ISO 45001, that is your occupational health and also environmental standard, that is ISO 1400, then also IEC 62941. And also we have manufacturing execution system, that is your MES, just for traceability, and also quality management system, collect and share quality information to realize the whole process, data transparency, just to do root cause and also solve problems on the line. Then we've got laboratory information management system, that is more of the whole process and coordinate, achieve optimum allocation of experimental resources and obtain reliability experimental data in time. Then the next product I'm going to introduce is the Guardian. As I just mentioned, firstly, we have the Explorer, then we have the Scientist, then we've got the Guardian and the Artist. So this is one of the product, this is the Guardian with an additional feature that is your anti-humidity and heat. So these modules, they come in the power bin of 595 watt peak and also up to 615 watt peak. And it also adopts the HPBC technology, which is the hybrid passivation back contact. And the wafer size it takes the rectangular new technology of the wafer, and the module size is the same as the previous one, and also the weight. So how did we come up with this technology? We have found out that these issues in terms of dumpy heat, dumpy areas, whereby you have water and moisture ingression on bifacial module glass of modules, and also sometimes also we have this issue on the back sheet if the module is also a monofacial. So that's where we came up with this innovation, whereby we looked at the key factors which affects the module stability operations. So we looked at three factors. That is your leakage degradation. So I mentioned about the water and the moisture degradation. So mostly the modules will go under frame water leakage. That is your water ingression. So the moment the water is combined with the cell, it will cause what you call um, adhesive yellowing because of the reaction of the encapsulants in the module. Then also we have what you call the hydrolysis reaction, whereby the moisture uh, is also get into contact with electrodes in the module. So you have what you call corrosion. Then it can also cause what you call hotspots and cause a fire. So those are the factors we looked at, and significant risk. You can find out that it can cause power and also cause fire and also power generation loss of your plant. So this feature, anti-humidity, is only what we have done is just to add the encapsulation material, because previously we used to use what you call the EVA, So what we have done, we have added what we call the POE, which I'm going to explain a little bit further in my next slide. So the anti-humidity heat, the advantages, it's high water resistant encapsulation solution, then high quality adhesive film process around the frame so that you don't have water ingression in the module or moisture ingression. Then we have the HPBC electrode process. So we optimize the electrode process. We have added a coating on the electrode to make sure that you don't have any corrosion. These modules, in terms of high power gain, the advantage also on these modules, it's first year, the degradation is 1%. And this second year going to the 30th year is 0.35% degradation per year, which is quite low compared to the mainstream product on the market at the moment. Then we have also beta temperature coefficient, which is minus 0.28% per degree Celsius. Then beta long reliability, I just spoke about we optimize the wafer. And number two, also we put what we call double POE in replacement of the EVA. So this is just the demonstration of the advantages, which I just mentioned. This is just the exploded view, how we assemble the module. We have the front glass adhesive film, then you have the cell in between, the adhesive film that is your encapsulation materials. Then you have also what you call the back glass. But if it's a monofacial, we have the back sheet at the bottom. So number one, I just mentioned about high water resistance encapsulation solution. This is one of the advantages. Then the second one, high quality adhesive film process, which we have actually implemented. Then also the HPBC unique electrode process, which is found in the processing. So this is just the structure of the encapsulation, which we are talking about, and the whole module. You can actually see that we have in between the adhesive film to actually encapsulate the cell. So it's just an exploded view just for better visualization. Then also on the other side, on the right side, we've got a high water resistant encapsulation. If you compare the two, we've got the high water resistance, then we've got the normal encapsulation, whereby you see that it's highly permeable. You can actually find water just penetrating easily into the module. So this is the the EVA and the POE structure. And after doing a lot of uh, quality inspection and quality uh, experiments, we find out that we've got a 30% reduction uh, in water vapor permeability on the POE material. Then we go straight to the electrode optimization. Just as a comparison between the TopCon and HPBC, that is our modules. You find out that the electrode corrosion blackening is highly identified on the TopCon on your right screen, and also the HPBC. You can see that it does not have that phenomenon. So this is just also another experiment which we have done, comparing the two, that is your HIMO X6 and also the TopCon you find on the market. And you can see that there's a significant advantage using the HIMO X6 with an anti-humidity and heat feature. Then also, with regards to the environmental durable, what we have done, we have also taken some samples and of 1 megawatt for the TopCon and also compared to the X6. And you could find that our modules performs much better and is only 45% of the TopCon damping heat degradation. if you look at your diagram on the left side. So I've just mentioned about in terms of degradation, the degradation is the first year degradation, which is 1%, and the 1% is affected by LID, that is light-induced degradation. Then the second year going to the 30th year, it's degradation at 0.35. So it's better than the top gun. As I just explained, so comparing the Hamo-X6 bifacial dual glass to the top gun, we find that the POE, which we have placed on the Hamo-X6, have got 7 times water vapor resistance compared to the EVA film, and also beta cell protection, which inhibits module PID degradation. And also we use what we call the 2 mm glass, and the front glass have also an AR coating, which actually improves also the absorption of light. Then the last but not least, this is also under the guiding, the module which I'm going to talk about. Actually, it comes in monofacial and also bifacial. It does have also an anti-dust feature on the module. So before we introduced this innovation, we did a survey and we find out that dusters have got a significant generational loss on all the sectors, from traditional CNI, high emission enterprises, and also other closing, and also even our household buildings. You find out that dust is a really big issue with regards to power generation. So we looked at effects of dust. So I've pointed out 3 here. The first one is the sheltering effect. So the sheltering effect, it's when when dust sits on top of the glass, covering the cell. So you have what you call reduced power generation. Then we have the second one, corrosion effect. The moment you have dust sit for a long time on top of the glass, uh, it causes what we call heat localization, thereby causing what we call rainbow patterns. And these rainbow patterns can also reduce your power generation. Then the last one is temperature effect. So due to the heat localization, uh, you have what you call induced hotspots on your module, which actually also reduce your power generation because of the increase of operating temperature of your PV cell. Then what we did, we did an experiment in the laboratory whereby we actually used sand, because if you go on your rooftops or whatever way your module is installed, you find out we've got this issue. Some they call it soiling, whereby the bottom side of your module is covered with soil, and what we did, we took different sizes of soiling. Then we did an experiment. We could find that at maximum 90 millimeters covering the cell, you could actually lose power up to 23.39%, which is quite significant. And we did 5 sample sizes. That's when now we came up with this innovation, whereby it's very simple innovation. What we did, we just changed the profile of the short frame to make sure that it flashes with the glass, so that when it rains or when you're cleaning your module, it just flashes all the dust away. So you will have advantages of high power generation. Then you've got also advantages of low frequency cleaning of the module. thereby also saving money or saving your operating cost during operation of the module. So this is just a demonstration of what I've just mentioned with regards to the Guardian series, the anti-dust effect, and here we go. All right, thank you. So going forward, I think the video, it was clear. So you have your only short frame. So I just want to mention also that the modules can only be installed in portrait, not in landscape, because we only changed the short frame. So the anti-design, let's just recap. Um, it has efficient performance, high efficiency performance, then aesthetic appearance. It's beautiful because of no bus bar in front, or the bus bar at the back of the module. Then yeah, it's also stable and also reliable. And the maximum power you can get from the module is approximately 600 watt and at an efficiency of 23.2%. So this is just for the monofacial, that is your degradation rate. So your first year degradation is 1.5%. Then from the second year going to the 25th year on the monofacial, it's 0.4. But for bifacial, it's 30 years and 1% also first year degradation. So when we did also just in terms of power generation, just to make sure that we looked at all scenarios. So what we did an experiment, outdoor experiment, and we could find that compared to the previous modules, we gained 6% generation of power. So you can actually increase your installed capacity of your plant. Then high generation gain at low module temperatures. So the maximum daily power generation gain after all this, which we have done on your right experiment and the location, we could find that at 1.86%, then average daily module temperature decreased by 2%, which is quite significant. This is just because I just mentioned also just to demonstrate in terms of maintenance cost of reduction for your anti-dust modules. So this is just a LONGi full scenario successful cases. So we've done a lot of projects and also we had the Panda, and also we did also rooftops of the artist, and also we did also the IMO X6 guiding, which I just mentioned on my slides. So I'm not going to go through all of them. So this is just previous technology which we've done, and these are the projects which we have completed. Thank you. are open for questions.
Okay, thank you for that training. If you do have any questions, please feel free to drop them in meeting chat. I see Jama has a question, so Jama, you can go ahead. I think you can unmute yourself.
Okay, thanks, Alton. Hi, Shatura. I just have
Thank
a
you.
question, just going back a bit, on the localized heating. So in that case, you mentioned where the dust particles sit on the panel, right, which causes localized heating, and that's also a form of shading. So I wanted to know, that localized heating, is it for when there's constant shading, or when shading, it can also occur like when shading occurs like just over like a certain hours, let's say in the morning, there's shading on a specific part of the panel.
All right. Thank you very much for the question. The localization of heat because of shading. Uh, this one is it's a consistent, it's a constant shading which we are talking about. So if the module is constantly blocked, it actually causes induced hotspots. Then we have also shading, whereby you have, like, for example, if you install your modules on top of the roof and there's a chimney, and but it moves as the sun moves as well. That one is just it's just shading, and it won't have an effect on the module.
Okay, sure. Thank you. And then
Mm.
another question on that. I know modules have like bypass diodes to reduce the effect of that shading on the production. Um, do you know the setup of the bypasses on these modules?
Yes, so what we have, as you can see, these modules, they are divided. For example, if you look at the half-cut modules, they are divided into two sections. And on these modules, we've got three bypass diodes. And on these bypass diodes, each diode works with uh, four strings. So we've got two strings on top and two strings at the bottom. And these are all connected into series. So they work with each one diode. So the whole module, is actually uh, um, uh, it works with three diodes. I don't know if I've explained. So if there's shading on the other side of the module can still operate with other diodes as well. So if you block one section of the cells, then you can still generate from the other section of the module.
Okay, so if there's three bypasses, so there's four sections, right? So if
Yes,
one section is blocked, it means that um 3/4% of the module is still in operation.
correct.
Oh,
Correct,
okay.
yes.
Oh, okay,
Yes,
no, sure.
correct, yes.
Thank you. That makes
Yeah,
sense.
yeah.
Cool. Thank you.
Any other questions?
Any more questions? So Aaron, who supplies this product? So Aaron, we do have our offices there in Joburg. So we do supply LONGi also there in Joburg. We have a warehouse there in Campton Park. So if you can just drop your email, and then I'll just one of the sales managers your email and your company details, and then we'll just get back to you with on that one.
Oh, okay. You only supply per order via email. I can't just walk in there.
Oh no, you have to make an order online, and
Uh,
then we get it ready for you.
okay, cool. What is the price range of this, the Guardian more particular?
So the sales manager will then be in contact with you on that one to give you pricing.
Oh, okay, cool.
Yeah.
All right, thanks, man.
Okay, perfect. If you can just drop your email, and then we'll just make sure we get back to you.
Okay, cool. Thanks.
Thanks. Okay, so if we don't have any questions, I think we can then call this the end of the training. And I'd like to thank everyone for being here, being part of the training. And if you do have any questions after the training, please feel free to then drop an email to IBC, and then we'll then assist you with any technical inquiries. And yeah, thank you everyone for joining, and enjoy the rest of your day.
Thank you.